Pumps are mechanical devices that transfer fluids, liquids, or gas in different locations by increasing the fluid's energy, typically converting electrical or mechanical energy into hydraulic energy. Pumps are broadly classified into two main categories based on their method of energy transfer. First, dynamic, centrifugal. And second, positive displacement or PD pumps. 1. Dynamic or centrifugal pumps add kinetic energy to a fluid by increasing its velocity through a rotating mechanism. Working principle of pumps use a rotating impeller to create centrifugal force. Working principle of dynamic pumps use a rotating impeller to create centrifugal force. Fluid enters the eye, center, of the impeller and is accelerated outward at high speed. And these high-velocity fluid enters the widening spiral casing, volute. Its kinetic energy is converted into pressure energy before exiting the discharge port. Further subclassified dynamic pumps. A. Dynamic pump with radial flow. Fluid enters axially and exits perpendicular to the shaft. Best for high pressure, low flow. Circulating water in HVAC systems or moving liquids in chemical plants. B. Dynamic pump with axial flow. Fluid moves parallel to the shaft, ceiling fan or boat propeller. It pushes air or water in a straight line, parallel to its rotating axis, create a high flow with relatively low pressure. C. Dynamic pump with mixed flow. Combines radial and axial flow characteristics. Common. Use. Water supply, chemical processing in industrial applications, and irrigation. 2. Positive displacement pumps. This pump moves fluid by trapping a fixed volume in a chamber and forcing it into the discharge pipe. Gear pumps, piston pumps, diaphragm pumps, lobe and screw pumps. Working principle of PD pump. PD pumps use mechanical action to expand a cavity on the suction side, drawing fluid in, and then move that cavity toward the discharge side, squeezing the fluid out. PD pump provides a constant flow rate, regardless of system pressure, by trapping a fixed amount of fluid and forcing it to the discharge. Unlike centrifugal pumps that rely on centrifugal force, all pumps work on pressure differential. Create a low pressure area, causing higher pressure fluid to flow in, whether by impeller rotation, centrifugal, piston movement, or meshing gears. In pumps, there is energy transfer by mechanical energy to the fluid, increasing its pressure and potential energy. Gear pump. Simple type of rotary pump, where the liquid is pushed around a pair of rotating gears to trap fluid between teeth and the casing, moving it from inlet to outlet, ideal for oils and paints. Piston, plunger, high-pressure applications like car washes. Diaphragm, used for corrosive or hazardous chemicals. Screw pumps. One or more rotating screws trap and move fluid along their threads. Piston, plunger. Piston reciprocating in a cylinder creates suction and pushing fluid to discharge. Create high pressure. Modern hydraulic pumps can achieve efficiency up to 90% and generate immense pressures plus 600 bars for tasks like rocket engine control and deep-sea applications, leveraging principles like Bernoulli's law.